Alright guys, how you guys doing?
Good.
You guys have a good weekend? Doing anything fun?
Yeah. Went away.
Hey, there you go. What is it going? Alright, so last couple weeks, what have we been learning about? What have we been talking about here in class? Triangles. Talking about different triangles, right? Exactly.
Perpendicular lines.
Perpendicular lines, that's good.
Parallel lines.
Parallel lines.
Angles.
Angles, right? We've been talking a lot about angles. What are the different types of angles that we have?
Cute.
We have a cube, right? Cute little one. What other ones? Obtuse. You know what an obtuse angle is? There you go, right? Bigger than 90 degrees. What's the last one that refers to angles?
Right angle.
Right angle, exactly. That's very important. So, right angle. Alright, what's some other stuff we talked about? Congruency, right? Talked a lot about congruent, when different things, when sides or angles, have the same length, the same size. Similarity was another one, right? We just talked about that a couple days ago. Alright, so good, those are some good things. These are some things that we'll be using a little bit today in class. I can't fix this. Alright, so I'm going to give you guys a little sheet. We're going to do a little fun little activity today, alright? Yep, and put your paper away. You need to pay attention, alright? Sorry. Alright, so on it, I want you guys to write 2 different points on there. They don't have to be close or far. Just don't make them too close to each other or too far away. Just kind of 2 points on the page anywhere. Anywhere you like. Alright, so then from there, I want you guys to draw like a blob or a shape or just something in the middle of those 2 points such that there's no direct line between those 2 points. So there's something in the middle where you can't go on a straight line from those 2 points. Alright, good job. Alright, so now let's say, you can put your hand. Alright, so now let's say you're like in a car, and you start at one point, and you need to travel to the other point only using straight lines. So let's say you can go bounce off a wall or off the blob that you guys made, but you have to get from one point to the other only making straight lines. Go and try it. Alright, good job. We got some cool different things here, right? Alright, let's take a look at Renee. Alright, yeah. So he traveled from one point to the other, right? Took a little bit of different route, did a couple different things. But what if this was like a realistic thing? What if this is like on a mini golf course, right? And let's say you have like a hole and where you're starting at. And you have a big thing in the middle. Would it be realistic, the way Renee drew it, to go from up here over this way, that way, bouncing off water or so?
No.
Is that realistic?
No, it wouldn't. If it was a car, that would still be okay. But in a realistic mini golf course, that wouldn't really work, right? The bounces wouldn't really make sense. Casey, yours actually looks pretty good. Let me take a look at that one. Good. So she had her 2 points here. Is this a little bit more realistic? If you bounce the ball up against this wall and it comes against this one?
Yeah.
Yeah, right? Why would it be more realistic? Because what?
There are less lines.
Less lines, exactly.
It's hitting something and it's making the ball change direction.
Yeah, right? It's bouncing off a wall and going up against that way, right? What would you think like in pool? In pool, how would you do it? Like, you bounce the ball off of the sidewall, right? And it comes off to go into the other part. Alright, let me show you a little bit of demonstration with the tennis ball. So just go and come up here. I'm going to do a little bit of a demonstration, alright? So I'm going to throw this tennis ball up against the ground and bounce it to Justin. I want you guys to look and try to observe and notice different things about the ball going down and bouncing up, alright? So let's take different notes. Alright, you ready? What do you think?
I think you have bad hand-eye coordination.
Don't hate on the teacher. Okay. So I have bad hand coordination. What else? What else do you guys know about it?
The path the ball travels looks like a V.
Yeah, it kind of looks like a V, right, as it came and bounced down. it bounced up and kind of had a little V shape, right? What else do you guys notice about how the ball bounced when me and Justin bounced it?
When it went down, it went up in the same angle.
Yeah, exactly, right? So, my marker go. So when we bounced it down, it came down at the same angle. So I'm going to draw Justin. Justin's much taller than me. I'm a little short guy. And so, when I bounced the ball to Justin, it went down, and as Liam said, it came up at the same angle, right? So, if this angle is the same as that angle, what word is that called? Congruent, right? That's what we talked about in the class. It is a congruent angle. Good job. So, and then when we have congruent angles, we write this cool little thing, whoop, whoop, to indicate that they are congruent. Alright? So now they got disappeared. This is kind of a little demonstration of how the ball is bouncing against the ground and going back up. How is what I have any different than like what you guys have on your sheet?
You don't have the lines on the side.
Yeah, right? You guys don't have those little lines up here. Alright? So go ahead and draw those lines on the side. Should we just down with it?
No, it's fine.
You got it. So we just have those lines in there, right? Okay, now when we draw this line down here, right, what kind of angle does this make? It's got a cool special angle right here. What does that make?
Right angle?
A right angle, right? Because when it intersects, right here, makes a right angle. How many degrees is a right angle?
90.
90 degrees. Exactly. And write this little square thing right there to indicate that it's a 90-degree angle, a right angle. What about on this side? Does it make the same thing? Is it different?
The same.
It's the same, right? Because it did that same point, drawing it down, and intersects at a right angle. Alright. Okay, so now we have two different figures. What kind of figures is it?
Triangle.
Triangles, right? So when we drew the line down, we made two different triangles. What about more explicitly? What's the specific type of triangle are they?
Right triangle.
Right triangle. And why are they right triangles? They have a right angle, exactly, right? For a right triangle, it's got to have at least one right angle on it. Okay, so now I got two right triangles right here, right? What else do you guys notice about these cool triangles? Is there anything similar or the same, or what do you know about them?
Well, they look the same, but they're different sizes.
Yeah, they look the same, right? This one's just like a bigger version, right? It just looks like it blew it up a little bit and kind of flipped it around this way. We actually have a special word for that. We learned that a couple days ago. If we have one that's the same looking like it, but a different size, what is that called? What kind of triangles are they?
Similar triangle.
They are similar triangles, exactly. Good job, Justin. They're similar triangles. But how do we know that they're similar? What would make them similar? How do we know that this is really the same size as that?
The angles.
Exactly. We know about the angles, right? Because we have right angles that are congruent here, and we have the inside angles that are congruent here. And so now we know they look the same by angle similarity. We know that these two triangles are similar. Good job, guys. That's a tough thing to get. So, next week we're going to start using these, and we can understand a little more about proportions. Sounds good? I told Greg to give you next week.
Yeah.